Hi, I'm Ishita Moghe.
And I'm Kim Solez, and we'd like to tell you about the Human Cell Atlas project and this long series of other things in the context of human-centered computing, human-centered design, World Future 2018, human purpose, and what you can do to promote it.
So first of all, we wanted to talk about the Technology and Future of Medicine course, which has been running since 2011. It's both an undergraduate and graduate course, and basically, as its name implies, it has a very future-based focus. Since 2011, I think it's grown a lot, both in terms of the number of students enrolled in it and the topics we discuss. For example, last semester when I took the course, we talked a lot about the Human Cell Atlas, which is one of our focuses for today. And we talked about just how far-reaching its consequences are going to be, and just the fact that technology within medicine is increasing at such a high rate.
So the Human Cell Atlas is also related to my other main interest, which is the BAMF classification, the BAMF consensus process in transplant pathology, and the BAMF Foundation. And as you'll see in this presentation, that is related to the Human Cell Atlas in that the latest paper we've published about a new BAMF classification of tissue engineering pathology includes quite a lot about the Human Cell Atlas and explains the reason that the two are sort of dependent upon each other. We can't really have a working classification of tissue engineering pathology without having the Human Cell Atlas project. So this is just some pictures from the existing BAMF classification of transplant pathology, allograft pathology, which is a scoring system used worldwide. Surprisingly, there is no competing system, so everybody uses it throughout the world. But it's for the transplantation and interpretation of what's going wrong in allografts, that is, unrelated transplanted organs that the body may reject. In tissue engineering or regenerative medicine, you could put in organs that would be immunologically identical to the recipient and so would not reject. But there would be many other potential problems there. So this is our recent paper from this month's American Journal of Transplantation about this new BAMF classification of tissue engineering pathology. And down at the bottom of this page, you want to tell us what you see there?
Yeah, one of the three, and the first one that appears, one of the three abbreviations is the Human Cell Atlas Project, or HCAP. So we can really see how integral the HCAP is for tissue engineering pathology and for regenerative medicine.
So a lot of what tissue engineering pathology is getting the right cells in the right places in a bioengineered organ. It sounds simple if you know what the right cells are, if you know how many cells and what the cell types are. So just as an example, this is a picture of a kidney where you've flushed out all of the cells that were originally in that kidney, and then you infused stem cells into it, and then sometime later look at where the stem cells are. And you get very odd things like cells that look like cells that should only be in the filtering unit of the kidney, the glomerulus, that are out in the interstitial compartment. and many other abnormalities of things that shouldn't be quite like that. And so that's what tissue engineering pathology will be. So the Human Cell Atlas project then solves this looming thing missing from tissue engineering pathology, which is knowledge of what the normal cell types are, how many there are, and without that, I think the whole classification really wouldn't work. So this is something very recent. Prior to the last few years, people thought that the transcriptome, looking at RNA sequencing in organs in the human body, you would do by taking fairly large pieces of tissue and just looking at what the average transcript is in all those cells. And you can imagine how much more powerful it is then to be able to look at single cells, the individual cells themselves. And we first became able to do that. Aviv Rega did 18 cells at a time in May of 2012. And there's been a very rapid increase in the number of single cells you could analyze at one time. And you can tell lots of different things, not only the type of cell, but the state, the lineage, transitions, and location. So many different parameters can be determined, and we think that in every organ in the body this will greatly increase the number of cell types and our understanding of what those cell types do. Now in the kidney, we've been assuming that the number of cell types would double, that is from 26 to 52, and we thought that based on the analogy between the kidney cells, where there are 26 cells in traditional thinking, and the white blood cell system, where there are also 26 cell types in our traditional thinking. Now, a subset of white blood cell types are dendritic cells and monocytic cells. And so there's a very interesting study that has this diagram to show that the original cell classification had 6 cell types in it. And now there's a whole new classification and with more cell types. So I looked at that and I thought it was 12. And then Ishita found another article. You want to tell us about the
Sure.
article by Moss? Yeah.
Yeah, I found an article that was kind of explaining this paper, and in its title it said that it went from 6 dendritic or white blood cells to 10, and it said that right in the title. So I was a little confused as to why it would be 10 instead of 11 or 12.
Yeah, so suddenly we thought, well, this whole simple concept of doubling the cells maybe really doesn't work. But it turns out that that article is in a newsletter. It's not really in a medical journal or anything. It's in a newsletter. It's just one person's opinion reading the other article. They're not one of the original authors. What did the original authors write about? Well, every time they wrote about this, they said that the number of cell types was 11, 6 and 4 plus 1. But they also said toward the end of the discussion that they thought there were cell types they could not detect. So that makes me think that 12 is still really the right number, but we thought for a while that we were on shaky grounds finding an article that specifically said there were 10 cell types. But anyway, so we're sticking to this idea of in many organs the cell type numbers will double, which is kind of interesting. Want to tell us about the Hitchhiker's Guide to the Galaxy and
Sure.
the meaning of life? Yeah.
Well, basically the Hitchhiker's Guide to the Galaxy, it says that the meaning of life is the number 42. But at least for kidney cells, we currently have 26 in our classification. So we're thinking that after they double through the HCA method, it should be closer to 52.
So maybe the meaning of life is really 52 and not 42. So it was traditionally thought there are about 300 cell types in the entire human body, and probably that is going to greatly increase as a consequence of the Human Cell Atlas project. It's very cheap to analyze the cells in this way. At the time that this slide was written, it was 15 cents per cell, but it's now down to 4 to 6 cents per cell, and dropping still further. And it really brings it into a sort of practical area where people can actually afford to do this. And it's related to many existing known disease states. There are already disease processes that have been analyzed in this way: autism, muscular dystrophy, Rett syndrome, cardiac fibrosis, obesity, and Crohn's disease. Now let's talk about the urine. That's another area where we had some shocks in terms of the literature. Do you know that the idea that mankind has been examining the urine for 6,000 years occurs in many textbooks and other sources, but it all goes back to one reference from 1911, and this is what that reference looks like. It's a book called The Evolution of Urine Analysis. Pretty impressive, eh? A historical sketch of the clinical examination of urine. It's got this pretty picture in the front matter, and the strange thing is there's no author. It's published by the Burroughs Wellcome Company, and not only is there no author for the whole book, but there's no author for the chapter that everybody has been referring to that references this idea that people have been examining the urine for 6,000 years. So this is the first page of that chapter, The Evolution and Development of Urine Analysis. See, it's all well and good, but it has no author listed, and this is the page 12. Down here at the bottom of page 12, you see physicians at a period of about 4,000 BC had noticed various changes in color and constitution of the urine. Wow, so exciting, eh? So everybody who's been writing about the urine since 1911 has cited this and has assumed that we've been examining the urine since 6,000 years ago. Now the strange thing is written language began 6,000 years ago. Now this would indicate that actually we became interested in the urine very, very early on. Now that is possible. Now you've probably seen videos with this picture behind us. You probably wondered what this glass of beer was doing here. Actually, I'm not sure we know what it was doing here before, but we know its purpose now, and that is the only way that it could be true that one of the first things written about the urine actually occurred when writing began is if beer was a very important part of the society, the Mesopotamian Sumerian society that first did writing, and that because people were consuming beer, they were making more urine, and they noticed appearances of the urine. Maybe that's possible, maybe this picture makes sense, but maybe not. Maybe we're off by like 2,000 years, and maybe urine examination, although all the books say it's been around for 6,000 years, has only been around for 4,000 years. We intend to find out, and we'll let you know later. We're going to get to the bottom of this. Anyway,
So,
Moore's Law.
Yeah, Moore's Law is pretty relevant here because it says that computational power will double every 2 years, but the Human Cell Atlas is exceeding this by a lot. Basically, our ability to analyze cells is increasing at a huge rate, while the cost is decreasing at the same time.
So this is the article that shows that, and it even has the phrase Moore's Law in the title. Moore's Law in single-cell transcriptomics. So isn't that wonderful? Brings futurism together with the Human Cell Atlas project. And so this is that initial, so that first paper with 18 cells, what was in 2012. One cell, they first analyzed one cell in 2009. And then you can see things have been increasing very rapidly, and now by 2018, 2019, we're almost up to being able to analyze 1 million cells at a time. And if you think of the power of that, and the difference then between analyzing just the whole mass of cells together and analyzing individual cells, there's just no going back. I mean, once you start analyzing cell by cell, you'd never want to go back to just analyzing sort of an average value for a whole big mass of cells. It really is going to change everything. Change everything about medicine in general, kidney medicine, kidney pathology, and examination of the urine. So here is a graphic where I've superimposed Moore's Law, in other words, doubling every 2 years, on this curve of how many cells they're able to analyze at one time. And you can see this is way above the Moore's Law level. So you may be sitting there and wondering what you can do to promote this, to make things better, to get things going along the right track here, so that medicine can improve rapidly through use of the Human Cell Atlas project. And so one thing is that when groups of people sit around and decide what subjects are going to be in like summit papers and grand summary papers and then meeting programs, that they actually include this. You may think that such people always make the wise decision, but do you know about the Abilene Paradox? The Abilene Paradox is something very scary, where a bunch of people sit in a room and come up with decisions that absolutely every one of them, if they were asked on their own to decide about this, would be opposed to. But they think they're doing it because the other people want it. It's a kind of groupthink error. And so maybe that's why some large meetings and survey papers and summit papers have said nothing about the Human Cell Atlas and single-cell transcriptomics. The other thing is showing up at meetings and staying for the whole meeting. It seems like a simple concept, but right now, particularly many physicians going to regenerative medicine meetings, they just come for their own talk, right? There's a session they're supposed to talk, and they come for that talk, and then they sort of disappear and are no longer seen. And that doesn't create the right sort of culture within the physician community to kind of move things forward. So by improving all three of those things, the inclusion of the Human Cell Atlas in summary and summit papers in meeting programs and by people staying for the entire meetings, those things would all improve things. So this is Global Kidney Health Summit 2017, and I've actually written about this quite a bit, and if you look at the supplementary material for the tissue engineering pathology article that came out this month, a critique of this summit paper is there, showing all the important search terms that are missing. It's completely silent on human cell atlas, regenerative medicine, tissue engineering, ex vivo perfusion, artificial intelligence, artificial organs, and xenotransplantation. All of those phrases and words talk about things that are very much a part of the future of kidney medicine. And to leave them all out of a summit paper is just the most amazing thing. It's not just one paper, it's like a big issue of Lancet and KI with many different papers, and these terms don't appear in a single one of them. So that's really shocking. And similarly, meeting programs. The American Transplant Congress, the most important meeting in transplantation. There's been nothing about the Human Cell Atlas project there. And similarly, the USCAP, the US Canadian Academy of Pathology meeting, the big pathology laboratory medicine meeting, there's been nothing there. In fact, the first video I ever did on the Human Cell Atlas project was done right here in Edmonton, here at the University of Alberta, during the USCAP. I didn't go to the USCAP, and actually there was no information about the Human Cell Atlas at all delivered at the USCAP meeting. So by staying home and listening to me, people could learn much more than they could by going to this gigantic pathology meeting. So, yeah, and staying for the whole meeting at Human Cell Atlas and regenerative medicine meetings, that's also important, not just parachuting in. I think parachuting is always seemed kind of scary to me. So anyway, it seems better to just go by conventional transport, and go there from the beginning of the meeting to the end, get to know the people, improve the culture, that sort of thing. Meetings are more than just your own presentation and your own session. So, you may have noticed this word human has sort of a special reverberation for most human beings. They kind of they feel warm and fuzzy about that word because they're human and so on. So there are many other things you could imagine that the Human Cell Atlas could be tied to. One is human-centered design and human-centered computing. The idea of computers working for us, doing things to benefit human beings. Expandable nature of time. You can relate Elon Musk's activities to other things here. I have another video about that coming, and the idea of computer multitasking. And then finally, the World Future Society 2018 meeting in Chicago in mid-August has the theme of human futures, human purpose. And so human purpose, we thought a presentation on the Human Cell Atlas would just fit perfectly in that Chicago meeting, and we intend to make that happen. And so those are various different ways in which various initiatives with the word human in them could be related to the Human Cell Atlas project. So, in our original location with the Banff meetings, we were in a very rural location in Banff, Alberta, Canada, with the mountains and nature and stuff. We had mule deers poking their heads into the meeting rooms and stuff like that. And as you can see, we've come a long way. But anyway, we encourage you to engage with us about the things that Ishita and I have talked about in this presentation, and also take part in Human Cell Atlas activities. It can be applied to your own area of work. It can be applied to the thinking in whatever you're doing. Please do that and interact with us and others, and let's all move this grand new idea forward. Thanks very much.
Thank you.
Bye-bye.